In this video, we take a look at the merge sort algorithm. We will trace through the algorithm with a step-by-step example so you can see how it works. Take your time and pause the video when needed. Once you've mastered the algorithms in this section, take a look at SLR 8, Classification of Algorithms, which will go over Big O notation. This notation is a way of expressing the time complexity of a given algorithm. The time complexity of the merge sort algorithm is O n log n. Like all sorting algorithms, a merge sort is responsible for taking in an unordered or unsorted list and then returning a sorted list. It's one of the fastest and most efficient sorts available. There are three key characteristics. It's fast, it uses a divide and conquer approach, and it also uses a recursive algorithm. You can look up what's meant by recursive algorithm by going back and checking our video on recursion under SLR 2. We're now going to go through a step-by-step example of a merge sort in progress. When implementing a merge sort algorithm, we make sure to work on one side of a list at a time until we go as far as we possibly can. Let's see what I mean by that. Here we have our original unsorted list. We start by splitting the list and we end up with this. Now we're going to focus purely on the left hand side of the list, the DBHA. So we split the left hand side of the list to get this. Once again, we work on the left hand side. So we're working on the DB split and we split the left hand side of the list. Now we've ended up with lists of one item in each. They can't be split any further. So before we do anything else, we now merge the left hand sides. We compare the first item in this list here, which is D, with the first item in this list here, which is B. And we merge the list to put B before D. This new list has now been sorted. We now return to the other half of the list we were splitting. The first thing we do is split this list. We end up again with two single lists, both with one item in. So within these individual lists, the items are in the right order. We therefore now have to merge these two items. We compare H and A, the first item in this list, the first item in this list, and we discover A becomes before H. These two items in this list are now sorted in the correct order. Before returning up here and doing this, we now must merge these two lists. We follow the same process. We look at the first item in this list, which is B, and the first item in this list, which is A. A comes first alphabetically, so it goes here into this new merge list. Okay, A's gone from here now, so we take the first item in this list, which is still B, and the first item in this list, which is now H. B comes first, so it goes next. We now take the first item in this list, which has only got D remaining, the first item in this list, which only has H remaining, and D goes first. And finally we're left with H on its own, and that goes first. You can see that by using divide and conquer and recursion, we've taken this half of our original list, split it repeatedly, and then merged it, and they're in order. Now we've done this, we can return all the way to the beginning and repeat the process with the right hand side of the list. So the first thing we do is split the list on the left. We go left again and split again. We now have single items in our list, so we compare and put them in the right order. This sublist is in the right order now. We go back up one and we split. The items are in lists on their own. We compare and we merge. We then take these two lists, which we know are sorted, and we merge them. C comes before F. We then compare E with F. E comes first. And then F and G are in the right order. We can now see that these 4 items up here are sorted in order. The only step that remains now is to merge this list with this list. The process is the same as before. We compare the first item in this list with the first item in this list. A is first alphabetically. This removes A from this list. We now compare the first item in this list, which is now B, with the first item in this list, which is still C. B comes first alphabetically. We now compare the first item in this list, which now only has D and H in it, so we compare D with the first item in this list, which is still C. C comes first alphabetically. We proceed. We compare D with E, and D comes first. We compare H with E, and E comes first. H with F, and F comes first. H with G, and G comes first. And finally H. You can see, by using the process of divide and conquer and using the format of recursion, we can very efficiently and quickly take an unsorted list, repeatedly split and merge, and end up with a sorted list. Let's take this one step further and look at some of the pseudocoded algorithms that might be behind this. If you think logically, the fundamental building blocks of this algorithm must be split into 2 main parts. We need an algorithm or program for splitting lists into 2. We also need an algorithm and program, which we're going to call repeatedly, to merge 2 lists back together into one new list. These 2 helper programs, as I like to think of them, one procedure and one function, are called from our merge sort pseudocoded algorithm here. There are several key things to note about this pseudocoded function. It takes in one parameter, an array. That's the original unsorted list that we want to sort. We have an if statement here that says if the upper bounds of the array is ever 0, in other words, if there's only one element at any point in our list, then we know it must be sorted and we simply return it. We saw lots of occasions of that previously when we worked through the example. You keep splitting lists down and down and down until eventually there is only a single item in a list. When we have a single item in a list, we know it must be in the correct position and must be sorted. So this code is very important. We can also here see a call to split list. This will be called every time we wish to split a list. It will pass in the array we want to split and 2 other arrays, the new left and right half, which this array will end up being split into. We can also see that merge sort calls itself recursively. Work your way carefully through these algorithms and the previous example until you get a good understanding of how merge sort works.